Hello all, welcome to this lecture where we are going to talk about AI and ML applications. So in this lecture, we'll discuss when and where to use AI and ML, and also we will discuss when not to use AI and ML. So this is going to be an interesting lecture. Let's get into details. Okay, let's start with when we should be using AI and ML. The first use case would be increasing business efficiency. An example here is dynamic pricing and sales optimization. Online marketplaces, airlines, and hotels use AI algorithms to continuously adjust prices based on real-time demand, competition, inventory levels, and customer profiles. Next use case would be predictive analytics. And here an example would be demand forecasting for a fashion retailer. So a retailer might use ML models to predict customer demand for new clothing lines by analyzing social media trends, previous sales data, and customer feedback from pre-orders. Next use case could be recommendation system. An example would be content personalization. So a streaming platform like Netflix uses AI recommendation engines to suggest movies and shows based on individual viewing history, preferences, and trends among similar users. And the next and very important use case would be risk management. And an example over here is fraud detection in an insurance company, which uses ML models to detect fraudulent claims by identifying patterns in past fraudulent activities, such as unusually high claim amounts or repeat claims from the same customer. Now let's discuss when not to use AI and ML. And before we get into details, let's talk about an interesting real-life incident that occurred a long time ago in a large organization. A team of highly skilled data scientists were tasked with creating a ML model to predict whether an email address entered by a user was in correct format. The data scientists developed a machine learning model and trained it on a large dataset containing both valid and invalid email addresses. However, the model could only achieve an accuracy of about 70 to 80%. This is a common data science challenge where you reach a certain level of accuracy and then you try to improve it using various techniques. Despite their efforts, the team struggled to enhance the model's accuracy. And one day, a junior data scientist joined the team. After learning about the problem, he asked his seniors to give him a few hours to tackle it. He came up with a solution that achieved an impressive 95% accuracy. The surprise? He didn't use machine learning to solve the problem. Instead, he used regular expressions, or regex as we call it, to validate the email address. Isn't that amazing? So the point I want to emphasize through this story is that AI isn't the solution to every problem. It's important to understand where AI fits best and where it will provide a good return of investment, or ROI. Now let's discuss various scenarios where we should not be using AI, and also what are the various factors we should consider before deciding when to use AI and when we should not. Firstly, cost-benefit analysis. Before starting an AI project, ensure that the potential business benefits outweigh the cost. If the costs exceed the savings, it might be better not to proceed. And the second factor we should check is whether it is resource intensive. Training AI with machine learning requires significant resources. Processing power can be expensive and models may need frequent retraining. So if you don't have enough resources to frequently train the model, you may very well decide not to go ahead with AI and ML application. Next is impact on customers. AI models can influence decisions that directly impact customers, such as loan approval. In these cases, it is important that the models are trustworthy and transparent. So if there's a customer impact, and if you're not sure whether the AI model will be trustworthy and transparent, you may not want to use it and impact your loyal customers. Next factor is model interpretability. And what is that? It's the ability to understand how a model's features like weights or coefficient relate to each other and produce final results. For example, in a linear regression model, interpretability helps users understand how the input features contributed to the final prediction. And complex neural networks, while powerful, are often difficult to interpret. If transparency is a business or compliance requirement, simpler models may be needed, though they may result in lower performance. So we need to consider this aspect as well. If your business needs this, then you will have to check whether you can go ahead with a complex model, or if you use simple model, whether you will get the required performance. Next factor to consider is if rule-based systems are good enough. In some cases, a rule-based system may be preferable over AI. For instance, a rule could state that anyone with a credit score below 600 should be automatically rejected for a loan of $5,000 or above. This offers more transparency as compared to an AI model. Lastly, deterministic versus probabilistic systems. Machine learning models are probabilistic, which means it introduces variability in the results. So if your system wants a deterministic result, meaning they always want the same output for the same input, then a typical rule-based system would be a better option. So if consistency and determinism are essential, a rule-based system may be a better option. So that's it in this lecture, where we saw what are the various applications of AI and ML and when to use it and when we should not use it, and what are the factors we should consider before deciding whether to use AI or ML. So thank you. See you in the next lecture. Bye.